Hi my friend, welcome again. I'm going to teach you the most common fault on a dead motherboard step by step. So let's get started. So guys, we're gonna begin with the first cause that cause a dead motherboard. Of course, we're gonna see some live testing using the multimeter, and we're gonna pass through many motherboards in order to understand everything. So the first common fault is the power jack. Do you see, guys? This is basically type C power jack for this motherboard. Sometimes you can find this power jack for other motherboards. Sometimes this kind of power jack, the big power jack. So what is the most important here, guys, for the power jack is to check the path. Do you see here? Those paths. If we have a dry here for this one also, okay, if we have a dry in this path, the 19 volt will not pass to the motherboard, then you will get a dead board. Also guys, don't neglect this kind of jack, because sometimes you can find just a flexible cable, and this kind of jack you have to check these pins over here. Check if you have a dry hair or not. So this is the first cause that cause a dead motherboard, and many technicians don't pay attention to this easy failure. Of course, for some motherboard, as you can see, if you check here, for example, for this motherboard we have 19 volt. This is good. In this pin also we have 19 volts, so this is basically a good motherboard, okay? But if there is a dry hair, guys, even if you find here 19 volt in these two pins, because here basically we have a red wire, as you can see, we have red wires, means these two pins hold 19 volt. So even if this is the problem that some technicians are made, you check here, you find, for example, 19 volt. But if there is a dry hair, the 19 volt will not pass to the motherboard. So how can we check if the 19 volt pass to the motherboard or not? By looking to inductors or current sense resistor, like this one, for example. If we check it, we have 19 volt. Do you see, guys? Main 19 volt pass from the power jack to the board, to the motherboard, because here we have 19 volt. But in some motherboards you can't find here 19 volt in the input, but because we have a dry hair, okay, you will not find 19 volt in the current sense resistor, means the voltage, the B plus, is not distributed in the board. So please pay attention. For this motherboard, guys, for example, we have the power jack, we have here two inductors. So you can't find 19 volt here, but if there is a problem, a dry problem, it will not pass to the board. So always check these two inductors here, and also we have current sense resistor over here. So the current sense resistor is the bridge between the charge circuit and the rest circuits in the board. So always, even if you find, guys, 19 volt here, please check inductors or current sense resistor. As you can see, for all motherboards you will find current sense resistor. For this board, for example, guys, that contain just this kind of jack, integrated jack, if we go to the back, as you can see, we have the big inductor here, and we have the current sense resistor R010. This is the current sense resistor. So here you have to find 19 volt. So from this point, 19 volt will be distributed to all circuits in the motherboard. And the proof, guys, do you see here? We have these dots, means 19 volt is distributed to 9 circuits, to 3.3 volt circuit, RAM circuit, CPU circuit, to chipset circuits, 1.8 volt circuit, BIOS circuit, to the SIO, to the peripheral, etc. Okay, guys, so here always remember the current sense resistor are very important if you want to master troubleshooting and to isolate failure very fast. And in some motherboards, guys, you can find protection component, like for example, for this motherboard we have diode. This is a protection diode, as you can see near to the power jack over here. Guys, we have the power jack. Do you see? We have a flexible cable with the power jack over here, and we have a protection diode. So for this diode, you can just test it using the multimeter. So please pay attention. This is not a 10 ohm capacitor. It's like 10 ohm capacitor, but this is a diode. How we know? We have the reference here, PD, as you can see, guys. That's why mastery references is very important. I have a video that I upload to my channel about references, very important. Because sometimes you can find some components that are the same form, same color, same size, etc. So we use references to distinguish between that component. So to make things simple for beginners, you say, guys, between this component and this component, this is a 10 ohm capacitor, and here we have diode. We have PD for diode, and we have here PC. Do you see here, guys? PC for 10 ohm capacitor. Even we have the same line, as you can see, the same thing, but this is capacitor, this is diode. So if you didn't master references, especially for beginners, there is a beginner that can change a diode with a capacitor, but no. So guys, please, I invite you to watch the video about references in my channel, just for you to know about how to differentiate between components. Now let's test this component to check if this diode is good or not. You can test it using the continuity option or the diode option, or just to check 19 volt here. So let's try both options. So guys, we have a flexible cable, we have the protection diode. So let's put the multimeter to the continuity option. So always, guys, locate the cathode. We have cathode over here. We have this white mark or this line or bar here means this is the cathode. So we're gonna put the black probe in the cathode, and we have the positive terminal or the anode. Let's check. We have 600 drop voltage. This is good. So if I swap the probes, just to be sure, we have 1. Sometimes you can find 1000 because the diode is connected to the board. So this is how we can check this protection diode, or you can just connect the adapter. Like this, we connect the adapter, okay guys, and check 19 volts. Where? In the cathode, here, because the anode is connected to the ground. You see, this wide area means ground. So again, guys, let's move on the multimeter to 20 volts. Here we have 20 volts. So we're gonna put the black probe in the ground, everywhere in the ground, and then the red probe, this time not in anode but in the cathode, because the anode is connected to the ground. Here we have white area. Let's check. We have 19 volt, as you can see. So 19 volt is good. So this is a good protection diode. Of course, sometimes, guys, you can find fuse in place of diode. You can find a fuse. Okay, so for protections, we use diodes or fuses. So what is the next step? After checking the protection diode, we have to go and check for MOSFETs or switches. Guys, you see here, we have, this is the charge IC. Here we have the first switch, the second switch. So 19 volt will go to the first switch here. If we check here, we have 19 volt. Okay, so this is, as you can see, we have this dot or a small hole here, means this is the source, and over here we have the gate. Let's check the gates. We have 3.6 in the gates. Okay, so the 19 volts will pass to this side. Why? Because the gate over here is activated, as you can see, 3.6. So here we have 19 volt. Good. Then, as you can see, these two switches are connected together. Here we have drain, here we have drain. We will find here 19 volt. So here we have this point, means this is the source. Here we have the gate. Let's check. Also, we have 1.6 as a control signal, means we will find here 19 volt. So 19 volt travel from the power jack, passing through the protection diode, and then goes to the first MOSFET, and then here in the other side, and then to the second switch, and then in this side. So this is good. These two MOSFETs are good. Sometimes, guys, you can find just one switch. Okay, one switch, not two. But in some motherboard, you can find two switches. Okay. In this motherboard, for example, guys, we have the power jack, we have two inductors, and we have two switches. This motherboard also has two switches, as you can see. And then we have the current sense resistor. For this motherboard, guys, for HP, here we have the connector, the integrated connector. Here we have the protection diode, as you can see. And here we have a switch. This is basically a 3-terminal switch. So for this board, you have to pay attention to these pins here, to the diode and to the switch. So guys, always the same working principle. So I show you many motherboards in order to master and to understand 100%. So we have connector. This is the input connector. Okay. After that, we have two switches. After that, we have the current sense resistor, guys. And then, as you can see, we have the 3 volt, 5 volt circuit. Why? Because we have here a duplicated channel. This one and this one, inductor, MOSFET, resistor, capacitor, inductor, MOSFET, resistor, capacitor. Okay, so for 3.3 volt and 5 volt, you will find always duplicated channel. So guys, now we're gonna continue with other steps. So remember, we have seen the power jack, the current sense resistor, the protection component, it could be diode, fuses, or inductors, and the switches. The same working principle for all boards. We have the DC jack. Sometimes we find a flexible cable. We have protection component. We have switches for this board. And in the other side, we have current sense resistor. So if there is a problem in the power jack, there is a dry, the board will be off, dead board. If there is a problem here, for example, this one is bad, of course. How we can check? So for beginner, how we can check this kind of resistors, current sense resistors? Always you will find R010 for the majority, of course. For this board also, guys, here we have R010. Remember, always current sense resistor. Very important, because from this point, the B plus, the 19 volt will be distributed to all circuits in the motherboard. If you have problem with this current sense resistor, the motherboard will be dead motherboard. We have another board here. Do you see, guys? Let's zoom in a little bit. Do you see? We have R010 current sense resistor. Another motherboard, guys, a very clear motherboard, we have R020, the same, 010, 020, always this is the current sense resistor. So how we check, guys, how we check those current sense resistor? So let's check this one, and this one. I will show you how to test it, because if the current sense resistor is damaged, the 19 volt will stop here. It will stop in this side. It will not pass to the other side, so it will not be distributed to the circuits of the motherboard, including 3 volt, 5 volt circuit, RAM circuit, CPU circuit, etc. So to test this kind of resistor, guys, you can just choose in the multimeter the continuity option or the ohm option. So let's choose, for example, the ohm option, since it is a resistor, and then we will choose also the continuity option. So we have here in the ohm option. So let's check it right now. Let's begin with this one. We have 1.3 volt. Okay, very low resistance. Let's check this one, for example, guys. 1.2, 1 ohm. This one also 1 ohm. Okay, so about 1 ohm. Remember, about 1 ohm. But if you test the current sense resistor, for example, and you find something is open, means the motherboard will be dead motherboard. You have to replace it. You have to replace it, guys. And what is the purpose of this current sense resistor in the motherboard? The purpose, basically, guys, is to measure the current consumed by the board. Basically, we have another here. Do you see? We have R20. So this one is for the battery connector. So this one measure the current consumed by the battery, and this one here, this is the main on the master one, and this is the slave. This one measure the amount of current consumed by the motherboard including the battery, but this one it measure just the battery consumption in terms of current. Okay guys, so please pay attention to current sense resistor. The same thing guys for protection diode or fuse or inductor. The same thing, please pay attention. You can't find diode or fuse or inductor sometimes. So if this one is shorted, the motherboard will be dead 100%. And also pay attention to switches. Here for this board we have two switches because the voltage will pass in this direction through this diode, and then through this MOSFET, and then through this MOSFET, and then goes where? Goes to here, to this current sense resistor guys, and then it will be distributed to all circuits in the motherboard. I can even prove to you this part guys, please pay attention, very important and very exclusive. I will prove to you the part that 19 volt follow until it will be distributed to all circuits in the motherboard. This part is common in all motherboards. Please do not miss this explanation. Let's do it right now from the beginning. So guys, here we have the red probe in this side. So here we have 19 volt in these two pins because we have the red probe, and those for ground, and this one for ID for the battery. So if I put one probe here and go in the back of the motherboard to do diode, protection diode, do you see guys? We have continuity. After that I will put one probe here into diode and go directly to this side of this MOSFET, to the source. Do you see? Continuity. And after that the power will pass from here, as you can see, to this side. Okay, and then will pass to this side here. So from this side guys, if I put one probe here and goes in the back to the current sense resistor, we will get a continuity. Let's go to current sense resistor in the back. So guys, here we have current sense resistor, the black probe in the MOSFET. Let's check. Do you see? Continuity, direct connection in this side and also in this side, in both sides. Why? Because the resistance here is 1 ohm. So if this resistor is damaged, it is open, the 19 volt will not pass and will not be distributed to all circuits in the motherboard, and then the motherboard will be a dead motherboard. Guys, let's draw this schematic in the paper in order to remember it 100%, especially for beginners. So we have the power jack. We have basically two cable or two line that hold VN 19 volts. Okay, we have here the ID for the battery, and we have two connected to the ground. Okay, these two will be connected to this diode. Here we have protection diodes, as you can see, the cathode here, the anode connected to the ground. Okay, here we have the cathode. This is protection, for protection. Remember, very important. If this one is shorted, the board will stop 100%, will be dead board. Okay, so we have this one guys. After that, this anode, the cathode of this anode is connected to these two switches, as you can see, to these two switches, the first switch and the second switch. So let's zoom in a little bit to know exactly. So here for this one we have the source. This is the source here, and we have drain connected to the drain of the second switch, and then the source of the switch connected to the current sense resistor. So let's zoom out again guys. So we have the first switch here. Okay, let's see Q. So here we have source and we have the gate here. Let's see, we have IC. Exactly this IC. We can even see its reference. We have PU 4001. So PU 4001. Okay. This IC basically, it is the IC that controls. So we have the control signal goes to the gate here. So we have gate, we have source, 3 pins connected together, and the drain of this MOSFET, 4 pins, as you can see, 4 pins here, connected to another MOSFET, as you can see, to the drain of another MOSFET Q. So let's see exactly the references to be clear. So let's see this MOSFET. Over here we have the reference PQ3801. So PQ3801. For the second MOSFET, let's see. So PU4007. So it's not Q, but U. We have PU3801 and PU, as you can see, guys, 4007. 4007. Good. So after that, the source here is connected to what? To current sense resistor. Connected to current sense resistor, as you can see, guys, and of course the gate also here. We have the control signal for this 2 MOSFET. So the current sense resistor, let's see the other side. This is the current sense resistor, guys. We have PR4012. So PR4012. Okay, guys. And from this point, let me please use another color. Okay, so from this point, guys, where we have B plus, here we have B plus 19 volts. Okay, B plus, it will be then distributed to all circuits in the motherboard. All circuits, including CPU circuit, including RAM circuit, 3 volt, 5 volt, etc. So guys, this is the schematic for this board. This is how you can understand and go deeper into motherboard failure and diagnostics analysis. I told you that the current sense resistor is the bridge between the input voltage and all circuits in the motherboard. So if this resistor is open, the 19 volt or the B plus will not pass to other circuits in the motherboard, including, as you can see, the 5 volt, we have B plus, and also in 3.3 volt circuits. So the B plus is here because the current sense resistor is good. Also, we have 5 volt in this big inductor, and as you can see, 3.3 volt. And the same thing for the charge circuit, we have 19 volts because the current sense resistor is good. And also for the CPU circuit, this is basically the back of the CPU circuit. Also, we have 19 volts in all input component for the CPU. So guys, as I told you, don't neglect to check the dry in the power jack and the current sense resistor, because this small component is the bridge between the input and all circuits in the motherboard. The sixth cause is the BIOS, the basic input output system. Where is the BIOS? Over here, guys. Here we have the BIOS. So if the firmware inside the BIOS is corrupted, the motherboard will be dead motherboard. Of course, the motherboard can work sometimes, but you will get a black screen. So basically, to check if the MOSFET is receiving its voltage 3.3 volt, we can just check the pin number 8. We have 3.3 volt. Good. We have 3.3 volt. Why? For beginner, why this one is pin number 8? As you can see, we have this white mark here. We have this dot over here, means this is the pin number 1, 2, 3, 4, 5, 6, 7, 8. Okay, guys, we have 3.3 volts, means the BIOS receive its working voltage 100%. successfully 100%. Okay, so the BIOS should work 100%. If it doesn't work, means the firmware inside it is the bad one. And how can we know if the firmware is good or not? When you get a new boot laptop or you get a black screen, you have LEDs are on, but you have a black screen. All these signs means you have a problem with the firmware. So 7, what we have to check, the power button. Do you see, guys? This is the power button. If we check, let's check this side, we have 3.3 volt in this side, and this side we have 0 volt. This side connected to the ground, and this side we have 3.3 volts. So please, many technicians, ignore the power switch. If you have a failed, a shorted switch, means the 3.3 volt will be always in touch with the ground, means you will get a dead board, guys. Okay, so please pay attention also to this power button and how this power button works. So we have here, guys, 3.3 volt. If I press the button, as you can see, 0 volt, 3.3 volt, 0 volt, 3.3 volt, 0 volt. This is how the switch works. But when you get always like this, 0 volt, like this, okay, guys, means you have problem with the board. Means this one is shorted. It's not good. You have to replace it. The step number 8, guys, is the 3 volt, 5 volt circuit. So we check the power jack. I told you that pay attention to the dry hair in the input connector. Pay attention to this current sense resistor. After that protection component, switches. Of course, for some boards you can find just one switch. Charge IC. So if you get the control signals in these 2 switches, means the charge IC is good. After that, the BIOS, the firmware inside the BIOS, and the 3.3 volt in the pin number 8. Then the power switch. After the power switch, let's begin the deep work. Now we will go deep, guys. So the 5 volt, 3.3 volt. The big one here is for 5 volt. The smallest one is for 3.3 volt. Guys, the 5 volt and 3.3 volt are not normal voltages. No, this is the most important voltages in the motherboard after the B plus 90 volt. Without these 2 voltages, nothing will work in the motherboard. Based on 5 volt and 3.3 volt, all other voltages are generated, including the voltage for the RAM for the newest motherboard. Here, for example, we have the RAM circuit. In this inductor we have 1.5 volt. Why? Because the RAM here is DDR3, and in these capacitors we have 1.5 volt VDD, and we have 0.75 volt for VDD. But what is here the main voltage? This is basically the control IC that generate this voltage for the RAM. But what is the working voltage for this IC? If we check, we're gonna find 5 volt or 3.3 volt. So let's check the ceramic capacitors around it. This one, for example, we have 5 volt. Okay, guys, if we check this one also, we have 5 volt VCC. So here, guys, the 5 volt here is the input or the working voltage for this IC in order to get 1.5 volt. Without this voltage, the RAM will not be fed. I can even use the continuity option and check between this coil and this capacitor, and we're gonna find a direct connection. Let's do it. So let's put the multimeter to the continuity option, as you can see, and then let's put one probe here in this inductor, of course, the inductor, the 5 volt inductor, okay, and like this, let's check this capacitor. Do you see, guys? Okay, we have, as you can see, 0 in the multimeter. Direct connection, as you can see, guys. Okay, direct connection. Okay, guys, this is it. So without 5 volt, the voltage for the RAM will not be generated. Let's go deeper a little bit. So let's go back to the voltage option in the multimeter 20 volts. Okay, and I'll put the black probe in the ground, everywhere in the ground, and let's check another circuit. Here, for example, for this circuit we have 1.8 volt. This IC generates 1.8 volt. But if we look around this IC, we have 3.3 volt. Okay, we have 3.3 volt. So without this 3.3 volt here in this inductor or in this channel, this IC will not be fed or will not be working, then we will not get 1.8 volt. That's why, guys, I told you that the 3.3 volt and 5 volt are the most important voltages in every motherboard after the B+. I can even do the same thing and check between this point here, 3.3 volts, and this capacitor here. We have to find a direct connection. Let's do it again. So we have the inductor here. We have the ceramic capacitor here. Okay, guys, let's zoom out a little bit. Good. Okay, let's put the multimeter again to the continuity option over here. Okay, guys. So let's check. Good. Continuity option seated correctly. So, guys, if I put one probe in this inductor, in 3.3 volt inductor, let's put it here, for example, because the same thing. Okay, so one probe in 3.3 volt inductor, and let's go directly to this capacitor. Do you see this capacitor, guys? Over here. Do you see, guys? 0 in the multimeter, direct connection. I will zoom out a little bit. Direct connection, guys. You see, direct connection. So without the 3.3 volt, this IC will not be fed, will not be working. Thus we will not get 1.8 volt here for the RAM and also for the PCH. Guys, I hope that you understand. Don't hesitate to like the video, share, subscribe, and smash that bell icon for upcoming videos like this one. And for anyone who wants me as a mentor, you can just join me in my Patreon page and select, of course, the mentorship membership, and you are very welcome. I can help you one-on-one with your board failure until you fix it. Thank you very much, and see you in the next video.